Hello everybody, my name is Jason Kleberg. I'm from T-Mobile USA. From the engineering operations side. I've been at T-Mobile about 6 years, so been through quite a few evolutions within that company in terms of technology, architecture. One of the most recent challenges that we've had is evolving the backhaul to meet the needs of bandwidth performance that a lot of these new handsets and technologies are requiring. So I'm going to review some of the challenges and lessons learned. I think this will be interesting for not only wireless providers, but also some of the wireline providers who are reselling these services for other wireless technologies. So why Ethernet in the backhaul? The number one reason, obviously, customers use lots of data, and that just doesn't scale on TDM, as you can imagine, in terms of technologies, cost. Ethernet is a commodity, very inexpensive. We're able to see a lot of these feature functionality move directly into the RAN architecture instead of trying to emulate it on top. So again, it comes down essentially to cost and growth on the network itself. Ethernet is everywhere, so this is a very interesting topic that if any of you have shopped for services in the rural parts of the United States, they will try to sell you Ethernet. The quality, the actual underlying technologies and services are quite interesting in themselves. So to start, we'll go over just a brief overview of what the RAN architecture looks like. And RAN is just radio access network, essentially the last mile of how do I get customers from the towers to the MSO, anchoring, termination, peering, stuff like that. A little bit outside of this conversation, I'll be happy to answer some of those questions, as there does seem to be quite a bit of interest in wireless technologies. But we're really just going to focus in how do we up the speeds and feeds and technologies in that last mile. So speaking very generically here, what you really need to understand is there's a basic premise of TDM needs between the cell towers and the MSO. For 2G, GSM, edge speed, stuff like that, that was a couple T1s over a last mile provider through a DAX, terminated at BSC. 3G, we're just changing some of the names of what they're doing, changing the technologies just a little bit. T1 using ATM and IMA bundling provides higher speeds essentially to the user with release 99, HSDPA, stuff like that. But to really get the LT and HSDPA speeds to the customers, we can't really rely on those technologies as I mentioned before. So what we do essentially is we replace the middle with Ethernet IP statistical multiplexing. We push the intelligence out to the edge, so instead of having a pure TDM signal where it's a clock rate, I know every time if I miss a frame, errors, unavailable seconds, etc. Now I'm pushing that intelligence all the way out to the edge. I sometimes have to emulate some of those legacy services. We'll get to that in a minute. But for the most part, the evolution of the wireless architecture is going to Ethernet and IP. And each generation of these technologies pushes the intelligence out to the edge. So we have to do less of that tunneling, anchoring, overhead, stuff like that. So AAV is just a generic term for alternative access vendor, a provider who can do TDM today, Ethernet tomorrow, meet some of our needs, and we'll talk about some of that. So what are some of the challenges of moving to Ethernet, build or buy, right? In a perfect world, I would have my own TDM overlay, easement, equipment, fiber to the towers. Realistically speaking, that would probably be a 10-year commitment. Nobody's got time for that, right? Our core competency really is an over-the-top player, whether we're buying TDM, Ethernet, whatever. So that's a route we took. That's not saying in the future that once the optical facilities are to the premise that we don't look at buying it at instead of an Ethernet scale, buying it at a wave or whatever that technology is. We like wireline. We like the fiber, aerial, ground, whatever. We'll take it. Microwave, we're willing to work. And we also do, some of our own microwaves. But at the end of the day, I can't buy services to 30, 40,000 towers from 1, 2, 3 providers. Realistically speaking, I have 30 unique Ethernet providers today and growing. As you can imagine, that's a challenge when we're trying to standardize, right? Operationally speaking, that's the number one step that should be taken. We're willing to use licensed, unlicensed microwave for boundary and underserved sites. Again, that's probably in the 1 to 5%, not a lot in terms of the scale of the challenges. So the Metro Ethernet Forum, I think, is an interesting place if you're interested in how Ethernet maps to either a mobile backhaul service or some of the terms for the services and different technology offerings. But at the end of the day, it's, in my opinion, a standardization and certification effort. They don't actually map to service offerings today, which is a challenge for me. I can't go to 30 different providers and say, I need this grade of E-line or E-LAN. It must have these technologies. Again, as you can imagine, with 30 different technologies, providers, equipment vendors out there, there's going to be different underlying transport, PBB, packet-based, SONET. It's going to be a mix of everything. So you can imagine it's a big challenge. This is just a brief overview of we're taking the extrapolation of the earlier AAV service and adding what a microwave might look like. This is just a very simple point-to-point service extended upon. So again, the most important thing that we've seen both proactive and reactive is standardize the best we can, right? In a perfect world, I would hand a sheet of paper to 30 so providers and say, you must meet these requirements. At the end of the day, they do their best, and technology, business-wise, maybe they can't. So we kind of, we do what we can. Some of the most important things that you need to talk about: basic transport ordering, frame loss, frame delay variation, maximum and average. Obviously, this is very important depending on the technologies you're using for 2G emulation, synchronization, things like that. One-way maximum delay, this plays into the RAN budget. You can't induce 20 milliseconds into a 2G RAN when their max is maybe 30. Interface handoff specifications, this is important because you want to think about the future. You may be deploying today at a 20, 50, 100 meg CIR. You may be a gig CIR in the 2-year time frame. So certainly take into consideration contractually how to meet those needs. Forwarding characteristics. So this is maybe not so important when you're buying the traditional E-line or point-to-point services, but when you start talking about an E-LAN or E-tree, it becomes quite complex and unique how each provider will actually build a CAM table, a forwarding database. It's updating its rules in terms of flooding, bum filters, stuff like that. So it's very important consideration when you're looking at these technologies to think about some of that. And then the last one, obviously, is customer and provider monitoring. We're pretty upfront where we'll tell them exactly the granularity of the technologies we're going to be using to monitor their network. And ideally, we'd like to see the same thing on their end. So we can have a phone call, compare data. We see X, you see Y. In some worst case scenarios, I could call up my provider and say, I'm losing CCM packets or DMM. I've got a PVV of 900 microseconds or whatever it might be, and they tell me their ping works, right? So there's different levels of understanding. So make sure you talk up front and set expectations. Again, that'll pay off right away. The next is vetting the design with the carrier and obviously document it. Again, with 30 plus different providers, you would think that they would just solve all these problems underneath the sheets, and the business guys do. They're quite good at saying yes. When you start to ask the hard questions, how it actually works, you might be very interested in the technologies and the products and convergence and QoS and things that are really happening under. So it's important to partner, be transparent as much as possible both ways. It'll lead to a successful future lasting partnership. Some of the other ones, obviously, take into consideration failure, convergence, and diversity in design. You don't want to buy 1,000 cell sites from a provider that's got a single point of failure that they're using spanning tree with 45-second convergence, right? There's should be alarms and going off when you have some of these conversations with folks. Consider scaling. Build out normally takes 12 to 18 months for a lot of these folks. So if, one of the major attractions to Ethernet is I can make a phone call and get a CIR upgrade in a matter of minutes instead of TDM potential facility builds out mapping, stuff like that. With Ethernet, extremely quick, assuming that the physical backbone's got the capacity and capabilities. Again, that comes down to the initial MSA SLA in the build ahead schedule. Understand what that takes for each of them. You don't want to be caught with a bottleneck in the middle there. Understand how they do QoS, queuing, policing, basic things. At the end of the day, when we buy services, again, this is an implementation choice, we choose to do the QoS on our side. As you can imagine, with 30 different providers trying to interoperate with 30 different technologies, QoS designs, et cetera, it can get quite complex. So we essentially say we're paying for a CR. We don't want you to be anything else than a fast dump pipe. Consider future architecture. Again, it comes down to growth. Scaling few hundred megabits per second each of these cell sites. Consider your domain sizing. So this is where things may change a little bit between the wireline and the wireless, where we can have literally 1 million customers parked on a single logical endpoint. That can get quite scary at times. That's just the 3G. 2G, we can also adding on top of that. So as you can imagine, we're putting a lot of trust and risk. The reward obviously is high data speeds for users. It's transparent, but there is a significant amount of risk. So really, again, partnering, understanding what their network looks like and potential impacts to the services. So working with them in their product, their fiber, their facilities, their technologies. In a perfect world, I would have a cell site with 2 diverse TE tunnels, so any single failure would be minimized to an agreed, whatever that number is, 20 to 50 sites. Unfortunately, again, some providers, Ethernet, spanning tree, they'll lump them all together, and it can be quite a challenge. So it's important to really understand, ask those hard questions that'll pay off before those major events take place. And the last thing is, things will break, no matter what. Maintenance, failures, technology, hardware, whatever, it's inevitable. So it's important you understand during those scenarios how to troubleshoot it, what to look for, understand how the higher layer services, obviously if I'm running technologies out to the cell sites and the IP network can converge in a matter of seconds, but now I've got 1,000 cell sites resignaling across your core and that takes 30 minutes, that a few second convergence doesn't buy as much. So understand all the implications associated. The next one is using ratified technologies. Some of the interesting questions that come up of recent in talking with some of the major providers, they all offer layer 2 services. And again, in a perfect world, I need to standardize as much as possible if I'm going to support 30,000 cell sites in a nature like this. In our scenario and lessons learned that we've come, really having the provider be nothing more than a dumb pipe, and I guess that maps to an EVPL, E-line, whatever you want to call it at the end of the day. We've run into significant learning opportunities with the E-LAN services, building cam tables, bridging, bum filters, stuff like that. It really doesn't pay off at the end of the day, in my opinions. Layer 3 VPNs, very attractive. Again, if I can't get it across the country, now I've got another iteration of something which creates complexity. But it comes down to, at the end of the day, who do you want to converge? If you have true diversity to a group of sites and they're a dumb pipe, essentially you're the one that's converging based upon the technologies you're using. If we're using an ELAN technology, maybe it's a service over VPLS or BGP signaled, or maybe it's just raw Ethernet switches with the ZX optics or whatever. They're essentially the ones converging, right? So really take into consideration when you're partnering with these folks, understand the different convergence options and choose your own preference. The old pseudo-wire discussion. So 2G is not going anywhere. In a perfect world, all of my 2G infrastructure could be IP enabled. Realistically, it's 7 years old. They probably stopped developing software for it 7 years ago. It's a standard thing in the wireless industry. So we're supporting this for probably the next 5 years, realistically, maybe even longer in some of the smaller areas, depending on how some of the new technologies and spectrum gets allocated. So we need to consider, how do we support an over-the-top service, again, in another over-the-top scenario of Ethernet provider network, which obviously adds risk. Pseudowire is probably the most stringent technology used in terms of PDV loss, things like that. The 3G, 4G, whatever you want to call them, it's a little bit subjective there. When they're IP enabled, they're actually getting quite, they adhere well to events on an Ethernet and IP network, much better than SAT-top or any other pseudowire type technologies. So we did choose SAT-top. We're quite happy with it thus far. Obviously, we're still going through some growth pains. We considered CESO PSN. Our own implementation didn't have some basic AIS bits attached when there was a cut in the middle. So again, your mileage may vary, but these are things that take into consideration when a NOC's been watching for T1 alarms on a BTS for the past 7 years, and you take that away, that's a pretty big gap. So again, you know, probably the lowest risk thing is these providers are offering the T1 service out at the edge today. So the question comes up, why don't we just leave them? At the cost that we pay them a few $100s ultimately per T1, when I've got 100 megs next to it at a much lower bit rate, and I already have an intelligent endpoint out at that site, pseudowire technology starts to make some sense. Obviously, there's some risk in terms of implementation, technologies, network performance, but so far things are paying off. The next one is synchronizations. That's an interesting topic. Also, a lot of passion both ways. I could tell you what we've learned. 1588 is neat, and it works well for the most part. If all of the providers' underlying networks are very well behaved. And obviously, that's not always the case. Luckily, a lot of our 2G infrastructure was built out with a 911 service based around triangulation, so it had a local GPS feed. We're able to pull sync there locally. Another option is SyncE. Europe, I think, you know, in other locations that's a little more readily available. Not so much in the United States. So we're really focusing on 1588 and GPS as our two primary sources for people with tin hats and worried about the GPS dying someday. The next piece is really building that end-to-end intelligence. So this is something that initially was overlooked at our deployment of, we would just assume that the provider could tell us when things were working, and that's not always the case, and it's often not the case. BFD, right? Everybody likes BFD. It's now in hardware. It scales to the moon. It's extremely aggressive. We really like it. It's doing a lot of great things. It can tell us when to bring a service up or down in terms of Ethernet, MPLS, pseudowire, stuff like that. So highly recommend if you're looking at deploying technology services, that's an end-to-end protocol that you certainly look at. Support, another challenge as you can imagine. A lot of the big providers that, you know, the names you're probably familiar with, they've been doing Ethernet for a few years and are pretty well equipped on how to support it. The other 26 providers that we're working with, not so much. Ethernet's new. I gave you an example earlier where I can, you know, go in with my CFM stats and give them a run out, and they say that, you know, they can ping and get a response. Obviously, our ideals aren't lining up at that case. So it's important to partner with them, understand what you expect from them in terms of troubleshooting and understanding the networks, but also understanding what are the steps of triage. Where do you collect information? What is the next plan of action, et cetera? We don't want both sides of the party learning the networks on the fly when these events happen. RAN vendors are new at this. So 2G, 3G's been around a while. In some of my earlier slides, you've seen that mostly T1 based. 2G, obviously not moving to IP in our scenario for the GSM world. That's going to stay at TDM. Our 3G, 4G services are. So they've got Ethernet IP-enabled interfaces. They're doing their own signaling, bearer, voice call, et cetera, over this, which is really neat on paper, but as you can imagine, there's going to be some implementation challenges. IP Ethernet is not their core competency, to say the least. I can give you an example, implementation challenge we have where an RNC, which parks 3G traffic in the MSO may have 1,000 cell sites plumbed into it, or a couple hundred cell sites, with multiple RNCs. During some of our opportunities on the AAV network, we've learned that the programming on the cards, which lands that logical association between the cell site and the RNC, as sites fall off and try to rejoin, they compete for resources that's a shared on the CPU with things like spanning tree. So obviously something that's far from ideal when you can have a service level event drive network events, stuff like that. It's kind of a self-repeating cycle and can cause some real havoc. So certainly understand, ask those hard questions, bring it into the lab, try to scale it up, kick it, to really understand. A couple other scenarios, node B ARPs for each data connection. So you're no longer, with the normal 4-hour ARP timer, whatever normal endpoints would have at the scale we're talking about. Every single time a user does a PDP attach and requests data, they're doing another ARP request. Another one, the RNC sends directed ARPs as keep alive to gateway. So again, they're very unique and often troublesome, quirky implementations that we've seen. It's important the IP guys work with the RAN folks as much as possible to understand how they do some of this basic keep alive mechanism, because it's often a lot of room for opportunity. Another major challenge that we've had is, as a GSM TDM provider, is somebody's got to support this at a grand scale. And realistically, I can't have a TDM knock and a data or IP knock and then a services level knock, right? In order for a company to be successful, we need to, train our folks up. So we essentially took a couple hundred person TDM knock, brought them up to a basic level of understanding Ethernet and IP, and trying to standardize the process where they're capable of basic level troubleshooting, understanding some fundamental principles, correlation events, stuff like that. So it's extremely important that things like this are considered. Obviously, TDM folks' IP don't always mix. It takes some time. Realistically, it took us almost a year to get to a point where we can probably say we're more comfortable that folks are taking the phone calls of outages and what they do next. And there's ways to mitigate that risk, right? First of all, it's the training piece, but the next piece is we need to correlate events. So if I have 1,000 cell sites that maybe have a 2G, 3G, 4G service on it, and AAV has a blip at a catastrophic scale, we don't need BFD routing, pseudo-wire, X number of events, 2G alarms down, maybe there's some Ethernet O&M events taking place. So it's important you spend time in the FM category, fault management, understand where you can do intelligent correlation to roll up root cause type level events. We're lucky where we trusted one vendor to do the cell site intelligence and the MSO intelligence, where they can do that correlation locally and roll that up to our national FM system. So very important things. Obviously, you want to be able to solve the problem as soon as possible. 10,000 alarms that come in a minute time isn't going to help anybody. So procedures. At the end of the day, things will break, but they should really only break in a handful of ways. So it's important that you try to theorize how they may break. Excessive convergence on the provider, loss, links taking errors, services fail, devices fail, somewhere in between. Bring it to the lab, kick the tires, understand what happens in terms of what does your router see, do the protocols converge, what do the services on top see, 2G, 3G, 4G, so you can say, if you see X, Y, and Z, do this, if you see A, B, and C, do this, et cetera. So it's important and it's paying off. Device at the edge, again, this is an important piece. The cell site router, CSI, very generically. You want a robust, intelligent device that can do end-to-end protocols. Again, BFD we're using. It needs to be able to scale to the future. So if you want a 1 gig handoff from your AAV provider, it's going to need to do 1 gig per second at obviously some smaller packet sizes, since a lot of this stuff is encapsulated. Some basic troubleshooting events, ARP, ping, stuff like that. And ideally integrate O&M. You don't want a whole bunch of devices serially in line that's doing a lot of the same things. So CFM is, we'll get to that in just a second. So monitor what's important in the RAN KPIs. At the end of the day, the RAN is gospel. The IP may have an event, the RAN may not even blip, or vice versa. At the end of the day, we need to trust the RAN first and foremost. Second is the network devices, routers, BFD, protocols, pseudo-wire services, etc. That can give you an idea if something may have transitioned. And then the transport behavior. Again, the different services will react to different network characteristics, so it's important to monitor and understand it, but doesn't always mean it's an actionable event. So monitoring Ethernet service, obviously in the TDM world we've got errors, severely errored seconds, every frame is checked. It's quite robust. With Ethernet stat mux, we lose a lot of that. So 1731, 802.1 AG, essentially CFM's monitoring sending packets at regular intervals for delay, loss, etc., DMM, CCM. It's incredibly important that you can paint a picture before an event happens to understand whether things were good, bad, and different, but it doesn't mean it's the end-all, be-all. Another tool that we use is RFC 2544. It's essentially just a ratified test that's run in terms of delay, loss, jitter, back-to-back, bursting, etc. It's extremely important. Again, if I buy a 50 meg service, I expect 50 megabits per service to the end site. That verbiage can sometimes be unique to each of the providers, so it's important that you understand how it's checked, what the results look like for troubleshooting. Scaling. So you have to think about the future, right? You don't want to re-engineer this when you need a gig or 2 gig to the cell site in the next 2, 3, 4, 5 years. At the end of the day, it's an IP service providing IP connectivity. We believe the most stringent needs are actually based upon the pseudo-wire service over the top, that the next 4G, 5G, whatever they're going to call it, is actually going to be more forgiving, like SIP, Skype, stuff like that. We're already seeing it with our 3G when it was IP enabled. Obviously some room for improvement there, but for the most part it's quite forgiving and can recover on its own. Normal best practice, make sure that the design meets a 3 to 5 year plan. Again, you don't want to have to forklift things at this magnitude again, because we're talking in the millions of customers per backhaul. The last piece is scaling, right? So if we're going to do this 30,000 times, we're going to need to automate. And I'm sure a lot of people do this already, but if you're not, you want an authoritative database that says how these services are provided, what's unique about them, whether it's a VLAN ID, the CIR, different PDV, delay, exceptions, etc. But it's incredibly important to make sure you've got a consistent deployment across and one place to go and understand where these providers are unique. So I apologize, I moved a little bit fast at the end, but 2 minutes for Q&A. I'm happy to answer any questions. If we run out afterwards, I'm happy to talk with you.
Thanks for outlining all the items you had over here, and you are one of my near and dear customer.
I'm sorry, can you identify your name?
He's Shalom Akhtar from Comcast. So being my near and dear customers, I had one question. First of all, we don't do any spanning tree in our network, so hope you're happy with that one. Question number 2 for you is, you said 2G services are not going anywhere. Does it mean it's going to be BAU cap, no growth in traffic, and we need to execute upon the fact that we have certain set of traffic which we need to run as 2G?
So, yeah, so obviously 2G is not growing. We've got a finite amount of spectrum radio. It's actually, depending on some of our strategy in the near future, it will be remined. But at the end of the day, we need a 2G fallback scenario for people, A, with 2G handsets, and B, for 3G fallback to 2G services. So when we have to nail up, obviously with pseudo-wire, sat-top, once you say I need these 1 or 2 T1s, that bandwidth is already a foregone conclusion. So we don't see that type of bandwidth need services growing, but it also can't diminish until I can sunset my 2G network, period.
So the sunset process is a work in progress, correct? We do see some decoms happening as well. So does it mean it'll sunset at some point?
Again, realistically, in the 5+, I would say honestly, time frame, we would need 100% penetration of 3G handsets, 4G handsets in every one of the customers. Given the churn rates that I think are Fierce Wireless, you can look at some of that with 33 million subscribers. It takes time.
Right. Thanks.
Yeah. Thank you.
All right. Thanks a lot, Jason.